This is worksheet 6 of the equations packet, and in this worksheet we are going to continue with the theme of balancing reactions, but we are going to take it one step further. So in this worksheet you will be told the reactants of a reaction, and then you will be asked to predict what the products will be based on what type of reaction it is. And if you take a look at this worksheet, you'll see that you are either going to be dealing with, let me get my pen here, you are either going to be dealing with single replacement reactions, or you will be dealing with double replacement reactions, and we'll look at a couple examples of each. But you won't be asked to predict products for composition or decomposition reactions, which simplifies things a bit. Then, once you have predicted the products, you still need to make sure that you go back and balance the equation. You always want to balance an equation, otherwise it's not a true statement. So, let's take a look first at a single replacement reaction. They tell you that you have zinc, and it is reacting with silver nitrate. And they tell you that is going to produce something, and that is what you have to figure out. So you'll remember from some of the earlier worksheets that in a single replacement reaction, our single element is going to come in and take the place of one of the elements in the compound. And it matters which element it takes the place of in order for you to get the right products. What you need to remember is this note right here. Metals, in other words, positively charged things that we find on the left side of the periodic table, replace other metals that are also positively charged, or hydrogen, which isn't a metal but has a positive charge. Okay, so metals replace metals, in other words, positive things replace positive things, and vice versa. Nonmetals, which have negative charges, replace other nonmetals. Negatives replace negatives. Those things over on the right side of the periodic table. So, what you need to think about is the charge of zinc. If we look up zinc on the periodic table, we see that it has a positive charge rather than a negative charge. If we look at silver nitrate, we see that it's silver that has the positive charge, while nitrate has a negative charge. So what that means is that when zinc comes in to do a single replacement, it's going to come in and substitute or take the place of silver. So what we end up with as a product is zinc bonding to nitrate, and the silver getting kicked out all on its own. Right? Okay. Now, the one other thing we need to be very careful of, and this is a pitfall for a lot of students, is when you combine two things, like here we've stuck zinc and nitrate together, you have to think about their charges. You cannot just assume that one zinc and one NO3 are going to combine. You have to think back to Chem A, right? If we told you write the formula for zinc nitrate, you would go to the periodic table and you'd look up the charge of zinc, right? And you'd go to the periodic table and you'd look up the charge of nitrate on your list of polyatomic ions, and you would swap and drop. Remember that? You're going to have to think back to that. So in this case, yeah, you've got ZnO3. But if zinc had, for example, had a charge of +2, right, you would have had Zn, then you would have had NO3 in parentheses, and then you would have had a 2 outside of the parentheses, because you would have had to bring a 2 down. So you got to be very careful. Okay? All right. So in this case, we're good. And if we look, we've actually got a balanced equation too. All right, so we don't actually have to insert any coefficients. This is a pretty easy one. All right, so let's take a look at maybe a less obvious example. Here we've got aluminum, and it's reacting with copper sulfate. And they're telling us it's copper 2 sulfate, so copper with a +2 charge. Okay, so what is it going to produce? Well, aluminum has a positive charge, copper has a positive charge, sulfate has a negative charge. So the aluminum is going to take the place of the copper. Positive replaces positive. So what we end up with is aluminum bonding with sulfate, and copper is off on its own. All right, but let's think carefully about this. We cannot just assume that one aluminum bonds with one sulfate. Whenever we mush things together, we got to think about swapping and dropping. Aluminum has a +3 charge, right? Sulfate, if we look it up, has a -2 charge. If we swap and drop, we see that we actually get Al2 SO4 is going to have to go in parentheses with a 3 outside of it. So we got to go back and fix that here. All right. Okay. That means also, so let me erase this before I get ahead of myself. I don't have room for the next problem. That means we're going to have to go back and balance this equation, right? Because, oops, we've now got 2 aluminums here on the product side. So we're going to have 2 aluminums on the reactant side. We've got 3 sulfates over here on the product side, so we're going to need 3 on the reactant side. And that now means we have 3 coppers on the reactant side, so we got to have 3 coppers on the product side. All right. We'll do one more single replacement before we move on to the double replacement. This one is going to work just a little bit differently. Make some space for this problem. Alright, so here's what's a little different about this one. In this one, we've got the bromine, which is one of our Hofbrinkel elements, so that's why there's 2 of them. And it's reacting with lithium iodide. Okay? What's different here is that this is the first time we've looked at a single element, the bromine, that's negative. So in our compound, we've got lithium that's positive, iodine that's negative. Remember, negative replaces negative. So this bromine is going to come over and take the place of the iodine, because the bromine is negative and so is the iodine. Which means we end up with lithium and bromine combining, and iodine over by itself. And because iodine is one of our Hofbrinkel elements, when it's by itself, it always doubles up. So it's I2. Right, now we should double check. We can't just assume there's one lithium to one bromine. But if we look up their charges, sure enough, in this case, that is going to be true. All right, so now we just need to go through and balance our equation. So I've got 2 bromines on the reactant side. I've got to make it 2 on the product side, which means I have 2 lithiums on the product side. So I got to have 2 on the reactant side, which means I now also have 2 iodines on the reactant side. But that's okay because I've already got 2 iodines on the product side. All right, so those are single, and we'll finish up 4 and 5 in class. Double replacements. These are actually, in my opinion, a little bit easier because you don't have to worry about if the thing that's doing the replacing is positive or negative, and you'll see why. So let's look at number 6. Here we've got silver nitrate reacting with, oops, I'm going to leave a little space to go back and balance, reacting with beryllium chloride, right? And what is it going to produce? Well, remember back from previous worksheets that in a double replacement reaction, it's your first element in each compound that swap places. They flip-flop with each other. So what that means is that the beryllium is going to come over and take the place of the silver. So we'd have beryllium combining with NO3, right? And then the silver is going to come over and take the place of the beryllium. So we'd have the silver combining with the chlorine. Now again, whenever we smush things together, we've got to swap and drop to see how many are going to combine with each other. Right? So let's try it first for the beryllium and the nitrate. The beryllium has a +2 charge. The nitrate has a -1 charge. So if we swap and drop, right, I'm going to have 1 beryllium, but I'm going to have 2 nitrates. Over here, silver has a +1 charge. Chlorine has a -1 charge. So it's just subscripts of 1 and 1. Alright, so if I look, I see that on the product side, my nitrate has a subscript of 2. So I got 2 nitrates there. I need to have 2 on the reactant side, which means now on the reactant side I have 2 silvers. So I need to put 2 silvers on my product side, which means that now over on my product side I've got 2 chlorines. But that's okay because I've already got 2 chlorines over here on my reactant side. So this does require you to think back a little bit to Chem A. For some of you, that's going to be a little bit more of a stretch than others. So I want you to think a little bit about how comfortable you're feeling with this idea of swapping and dropping, like what we were doing here. All right. In class, the next time we meet, I'll have a little workshop for people who feel like they need a little crash course refresher on that. And then we will continue working on the problems on this worksheet, and also on to worksheet 7, which is just more practice with the same type of problem. You'll also notice if you look ahead that after this we just have extra challenge worksheets and then some reviews. So this is the last new required concept that you need to know for the equations unit.